So hi everybody. Sorry, we had some brief technical difficulties there getting the Hangout online, so we're starting a little bit late today. But I'm here for the data science community call with Mohammed Sarwat. Did I pronounce that right? I'm like hopefully I got that
Yes, it did.
good. Glad to hear.
Perfect.
So Mohammed is from the School of Computation Informatics and Design Systems at ASU. He's the director of the Data Systems Lab at ASU, and he's an affiliate of a place called Cascade, which is a great acronym for Center for Assured and Scalable Data Engineering. So welcome to the call. Thank you for joining us today.
Thank you so much, Andy. Yeah.
So I'd love to start off just by asking you a little bit about what the Data Systems Lab at ASU is. Like, what do you guys do? What is kind of the thing that you're trying to accomplish there?
Yes. We are at the Data Systems Lab. My colleagues and I, we solve problem. Mostly, we try to design and develop data management systems that are scalable and efficient. The problem we try to solve is, again, we try to build like efficient query execution, query processing optimization algorithms, data storage, scalable data analytics algorithms, scalable visualization. So we care more about the how to make, for example, geospatial data analytics specifically and data processing, how to make it scale to the terabytes and sometimes even the petabyte scale for geospatial data, and how to also make the analytics and query processing or processing of this geospatial data also interactive. And here comes the visualization, and here comes the if you want to use it in an application, how can you retrieve the data, retrieve the information for the user efficiently and in a fast way on, again, large scale data. So this is just a summary of the problems we try, we try to solve in the lab. And of course, there are several projects that cover more specifics on like to achieve that. Yeah, yeah.
Totally. So that's really interesting. So what is it about, especially specifically for geospatial data? What is it about, like, kind of where we are, this kind of time, what's happening in the world and industry and technology that's really driving the need to sort of, analyze those kind of volumes of data? Is there, what would be your feel for kind of why we need that?
Yes, this is an interesting question. So what we when we looked at if you look, I would say not far ago, like maybe 15 years back, geospatial data, we had geospatial data forever, but
Right.
back then, 15 or 20 years ago, it was just like you have satellite data, and it was not the available data for us, for analysts and for scientists and for it was not a lot. It was
Hmm.
just like gigabytes at the level of or the scale of gigabytes. And then you have like the companies that really had large scale data were like Google and Bing, the Google Maps and Bing Maps and all these kind of things. And again, the problems they were trying to solve were basically just like, for example, show me the path between point A and point B,
Right.
which was a hard problem back then, and it was a very like interesting service to provide for the users. These days, when you look at the amount of spatial data we have like tons of available geospatial data. What I mean by ton, like I mean it literally. So even when we talk about satellite imagery and sensing, I'm not sure if you get like people like there is NASA released this really hundreds of terabytes of
Hmm.
their Earth science data. And that was a couple of years ago, and they keep actually adding more data to that portal. If you look at how many people leverage this data, not a lot. A
Yep.
lot of this data is not actually have not been leveraged to the highest potential of it. The reason behind that, if you have hundreds of terabytes of data, is like if you go to a data scientist, to somebody working in physics, like anyone who wants to analyze this data to get some insights from it or explore it, they don't have a tool actually to allow them to do that. They don't have, I mean, a software tool to allow them to store hundreds of terabytes of data, load it, explore it, plot it, do anything like that. We have tools so far that allow people to do processing and again explore
Mhm.
small size of data. And they're amazing tools. Like we have, I don't want to name the tools that we have, but we have really amazing tools in the market that allow users to do analytics that we want to do, but on small scale.
Right.
And what I mean by small scale, in the scale of gigabyte or something, or even smaller for sure. But we don't have anything that allow us to again store, process, analyze, visualize, explore hundreds of terabytes, not
Mhm.
like even petabytes. So we don't have that. So the idea is there is a gap here, and this gap so far it's not filled. What we do in the data systems lab, we say, you know what, we realize this problem, and what we want to do is that we want to help data scientists out there if they have this scale of data and they feel clueless. What can I do with it? Okay, now people rely on, they use, like, for instance, like a data scientist, when they have hundreds of terabytes of data, the first thing they do is it just like, okay, I'm going to randomly select a gigabyte of that and
Right.
play with it with my existing tools or something like that. Is this efficient enough? Probably not. Uh,
Yeah. So,
so what we are,
so I
yeah,
mean,
what we are trying to do is that we want to allow them not to do that. We want them actually to work on this scale, but as if they're working on the small scale.
mhm.
So it's gonna, the same interface they have, the same kind of analytics algorithms they have, the same queries if you're using SQL, for instance, anything like that. The same SQL, the same analytics, it's going to remain the same. All what we want to do is that we want to change the infrastructure for them, the data infrastructure, so that it allows them to do the same job they want to do without waiting for years
Yeah.
to get the results of their
No,
analytics.
totally. I think, which I think what most people would appreciate, not having to wait that long to get the results out. So I think that's an interesting point you raised there, because I think that that is a strategy that a lot of people take when they're dealing with larger data sets, is to either subsample the data set or to chunk the data set up. Why, in your opinion, is that not a valid approach to looking at large data?
Sampling large scale data could be a good approach, but the idea, what kind of sampling technique you use, if you don't know the nature of the data you have.
Right.
So sometimes, like if you have super large scale data, um, there are there are things in the data that you don't understand.
Mhm.
There are patterns that you do not understand. So sampling, if you use, for example, random sampling or stratified sampling or any of the existing like de facto sampling techniques, it can be good and it cannot be good also. So
Right.
you don't know.
Yeah. You
And
may
you may
accidentally
be
sample.
building your whole, yeah, and you may be building your whole analytics on uh, on a wrong hypothesis, or
Right.
like, yeah. So and that's not cool because it's not going to benefit your business eventually. So
Right.
what I'm saying, I'm not saying sampling is bad, because actually even in our methodology sometimes we use sampling
Mhm.
to scale, but uh, this is our last resort, and we also make it tunable to the end user sometimes in the tools we have.
Yeah.
Like in the research, like in our research, we try first of all to scale out the problem. So we assume that, okay, users used to deal with one machine in the past, and a lot of people still do. Like
Mhm.
still, as a data scientist, they're always afraid to go out of core and have a cluster and all these kind of things. People are adopting these kind of mentality now, but we are helping them do that also in a seamless manner. Like if you have geospatial data and you want to scale it in a, you have a cluster of machines. You have like every company have like they have a cluster, for example, a Hadoop cluster or Apache Spark
Mhm.
cluster or any of these kind of. And what we do is that we tell them, you know what, you don't have to do a lot of work to set up to load your geospatial data in there. It's just a plug and play system. You just call a very simple function and load the data, and then load a set of other functions to kind of do the processing on the data, either filtering, integrating the data together, do the analytics, or do the visualization. for instance.
Yeah. So I mean, I
So
think that's a really good point. Like, so there's easy solutions exist and have done for a long time for large data sets that aren't geospatial. But there's I think some kind of confusion as to how those kind of systems can, pertain to geospatial information. So I would love to hear your thoughts on like what makes geospatial different, what makes it hard in that space, like how, like, why can't we just apply the same systems we use for like non-geospatial data to geospatial data, and to talk a little bit about your guys' solution, GeoSpark, and how that works and plays out.
this is a really, really, really interesting question. So what is the different like if you look back, is there anything special about spatial data?
Right.
Uh, in okay, the answer to that is it depends. So it's a yes and no. But yes, there are special things about geospatial data when it comes to building systems,
Mhm.
and the examples are, if you look at, let's assume you have an analytics task and you want to use Hadoop, for instance, to like map reduce and to do the analytics on the geospatial data you have.
Mhm.
You can definitely use it without any modification to the system to like map reduce to do the analytics. However, your system will take 10 days to run the task, okay? To run the analytics task, to do whatever. Let's not talk about specifics, what kind of geospatial. Let's say you want to do collocation pattern
Right.
recognition or something like that. Any kind of complex machine learning or on geospatial data. It will take 10 days, for instance, if you have hundreds of terabytes of the data that you
Mhm.
want to analyze. But if you design the system to be aware of the geospatial attribute in the data. And what I mean by aware of the geospatial attribute is, again, aware that you have a longitude and a latitude.
Mhm.
And the longitude and latitude is different than, for example, one-dimensional data in the fact that there is no sorting order that you can catch. The partitioning, like in regular data, when we do partitioning, let's MapReduce or Hadoop, there is, or even like database system, distributed database systems, you can easily do range partitioning, for instance.
Mhm.
Like if you want to partition on a single attribute, and it's going to work because it's easy to define the ranges that you can partition on, ranges of the value ranges that you can partition on. And you can achieve load balancing easily also that way. But in geospatial data, actually getting these load balance range partitions is not an easy task. It's a very complex task because
Yeah.
you don't have a single sorting order. If
Mhm.
you sort on the longitude, it's not going to be sorted on the latitude dimension. And if you sort on latitude, it's going to be sorted on the longitude dimension. And if you want to include the temporal aspect as well, so it's becoming even more complex. So
Right.
the multi-dimensionality of the data is what make it actually really complex to use the existing systems. You can for sure, it's going to run, it's going to return answer to you, but it's going to take 10 or even two orders of magnitude more time
Mhm.
to to get the answer to your whatever analytics or processing or visualization task. And in the current days, nobody actually is able to afford, if you like, if you want to do a task in one day and another tool will do it in 10 days or 100 days, which one you will choose, right?
Right.
So you'll choose the one that will finish it in just one day because there is time to market. There are issues like that. You cannot just wait. You don't have the luxury to wait for the answer. So the answer to your question is that yes, you can use existing systems as is. If you have, if you want to wait, like for wait more to receive answers for your tasks or analytics, if you don't want interactivity,
Yeah.
something like that.
So then the
And
real
if you wanna, and you will pay more for the
for the
cluster that
cost.
you have.
Yeah.
You need more machines to scale. Yeah, so that is the point also. Yeah.
So
If
so
you're willing
the,
to do that, it's fine. Sorry,
yeah,
please go ahead.
totally. So then GeoSpark is that's the part of the problem that GeoSpark's trying to solve, right? Is to like allow people to easily create these spatial indexes on clusters that mean that this processing is fast. So let's say tomorrow I find myself with a hard disk full of a terabyte worth of data, spatial data. How would I go about using GeoSpark to analyze that?
That's yes, that's exactly what GeoSpark is doing. So uh, GeoSpark is actually built with Apache Spark. Apache Spark already there. A lot of people are using it. So that's why we chose to do to do GeoSpark or to implement GeoSpark with Apache Spark. Um, the idea is that if you are a Spark user, if you're a data scientist and you've been using Spark for long and you want to use GeoSpark, the transition is very easy because it is the same ecosystem that you have.
Mm-hmm.
So you can use the same exact functions you use in Apache Spark. We have already, and we have, of course, an extra set of API functions for geospatial to deal with geospatial data. So in your analytics, you have probably three or four phases in analytics. The first phase is definitely loading the data. So we have functions for you to load geospatial data from different sources. And the main sources in geospatial data, we have, for example, an automatic function to allow you to load shapefiles.
Mm-hmm.
So if you have a shapefile and you want to load it into GeoSpark, just one function, give the shapefile, the link to the shapefile, either on local disk, as you mentioned, if you have on your local machine, or on HDFS, Hadoop file system, you can automatically load it. Once you load, and of course we can load it from PostGIS, from MongoDB, from
Yeah.
MongoDB Spatial, and all these kind of things. It it automatically does this for you, and it loads it into the cluster, the Apache cluster, Apache Spark cluster. And the second step that you want to do is that you want to do some kind of simple data preparation or data curation. This is done through, for instance, maybe the data is 100 terabyte, but you're interested only in 10 terabytes of the 100. Like, for example, you're interested for data that is located only in New York, in Manhattan. So
Right.
you want to do some kind of spatial filtering here. You filter data based on their spatial location. So we have also API for you to do that on the data in the cluster, and it scales also to data. So you can do a spatial range query on this. Let's assume you have multiple spatial data from different sources and you loaded them in the cluster and you want to integrate them based on their, okay, again, the spatial attributes. So we have also spatial join that can
Mm-hmm.
integrate the data together. So you have an API for that. So here you prepare the data, you manipulate the data a little bit. So that's the second phase, and we have APIs for you to do that in GeoSpark. This third phase is that you do the analytics, and analytics can be, like, for example, data mining, machine learning. So we have ways to for you to implement machine learning algorithm. You can implement, for instance, existing statistical. We already have implemented them, statistical analysis like regression,
Yeah.
geospatial regression, and geospatial interpolation, and all these kind of things. We implemented them, and it's just few lines of code using the APIs we have, and you already have it, and you can run it on the geospatial data. Another kind of analytics besides statistics and machine learning, there's also visual. Let's assume you want to build a heat map on the 100 terabytes of data that you have. We have we have another component in the system called Babylon, and Babylon allows you to apply visualization effects. The visualization effects we have are heat map, we have choropleth map, cartograms, we have also scatter plots. And again, it does the visualization out. It's also out of core. It's done on the
Mm-hmm.
cluster, which means that you can scale to any size of data you have. We massively parallelize the visualization task. We create the map tiles for you uh, to load, and you can of course overlay this with existing maps like Google Maps or the maps that exist. So this is also, we have a set of API for that as well. And the good thing is that since we have the whole stack, we also can co-optimize all these phases together to even get you the results way faster. Okay.
Mm-hmm.
We also compress the storage because we are the storage of the geospatial data. We build the indices. We do partitioning. so that the all this processing is done very efficiently for you
Nice.
as a data scientist. So the data scientist is the system is pretty much, if you're familiar with Apache Spark, the system is like plug and play for the data scientist. It's and of course you can do geospatial operations that we have for GeoSpark beside existing Spark operations that
Yeah.
Spark already provides for you. So you can do both of them together in the same program, right?
Nice.
And you can use for Scala Shell, for example, to do also interactive
That's
analytics.
really cool.
I'm
So
sorry, I talk a lot. So
no, it's
sorry,
great.
stop me
I think it's
anytime.
a really good overview of
Yeah.
the system and the platform. I think is something that's yeah, that I think people will be really interested to try out and see if it goes. So if somebody wanted to use it, is it a hosted service that you offer, or is it like the technology you have to run your own servers with? Like how do people interact with GeoSpark?
So far, we have the software available open source on GitHub. I'm not sure
Mhm.
if you guys. I provided the link to the GitHub uh, repository. So far, so we have the software artifact and it's open source. Uh, we have our own cluster, of course, but the service that we provide is we can help you install and deploy the uh, the software on your own cluster, on your own private. If you have like a private cluster in a company, for instance, so we help you we do the service of helping you out install, but we don't have our own server that you can run jobs on,
Cool.
something like that. So you need to have your own cluster, and you just install the software on your cluster, the same way you do with Hadoop, for instance, or
Right. Right.
Apache Spark or stuff like that.
Let's
Yeah,
go.
that's the status. That's our current status. Yeah, yeah, if
Yeah.
you want to use it. Yeah.
So that's big on the spot, but whenever you create technology like this, you see what people do with it, and you're always like really supportive of everything people do with it. But you always sort of have a favorite of like projects people have run using your technology. Is there any particular project that you've seen that uses GeoSpark that you're kind of particularly impressed by, or would be a really good use case or study for kind of the power of the platform?
Yes, I've seen. We have users use GeoSpark. We have like so far. So we have individuals use GeoSpark, and we have also companies. I don't want to name the companies or something like that, but
Sure.
companies that build like known companies that build maps and known companies that have like similar taxi services or something like that. So I don't want to name the company by name, but they're using it to do, for example, most people use it for data integration
Mhm.
and preparation. So what I mean by this is like, for example, if you have a lot of spatial data and you want to do a join on them to bring them all together to do some kind of analytics on top. So the people use it for that reason, because join is a very complex task and it's compute
Yeah.
intensive and memory intensive. So if you try to do it on, for example, systems like PostGIS or put like existing open source database systems or something like that, it's not going to scale for the scale of spatial data that you have. So they use it for that. Also, a lot of people are excited about our new. We just recently supported visualization, the visual
Mhm.
analytics I'm talking to you about. So people are so excited about it, um, but they're using it for exploration more, like as opposed to just like production things. So uh, they're excited about it because you can. Again, it's a plug and play for the same data that you have in the cluster. You can
Right.
build the scatter plot on the, for example, like the New York City. Are you familiar with the New York City taxi data?
I'm very familiar with the New York City taxi data. Yeah, I think
Yeah, yeah,
whenever we see large data, like large geospatial data, is kind of synonymous with that data set.
yes. So we use it. We use it as examples in our. So it's like we have like 400 gigabyte of the data or something like that, and uh, you can easily load that in the cluster and build all sorts of visualization on it. Like build heat maps, card. It's like plug and play, very easy and very fast as well. So
Cool.
it's people like really excited about that as well. So yes, the users are using it for different kind of different kind of scenarios. What excites me the most, and I believe excites a lot of people the most, is the visualization because you can see the results.
Yeah.
It excites me. Like I like just like the visual analytics and stuff. It gets you a lot of information out of the data, and it allows you to explore data in just one figure. So
Yeah.
it's like and that's basically what Babylon, which is a component of GeoSpark. That's what it does. Yeah.
Cool. That's great. Um, I think that's just kind of coming towards the end of our time. I wanted to give you an opportunity to just add anything else you wanted to say about GeoSpark or the work you're doing or anything you find interesting in the geospatial world just now. And then we can check to see if there's any questions from our audience. And I'll pick up those to you.
Absolutely. So all I want to say is that I believe like geospatial data is becoming really, really huge, and a lot of geospatial data is available. And we've been witnessing recently a lot of, like in the past, it was mostly in academia. Now we're witnessing a lot of like several companies out there. And for example, Carto is an example that are finding value in geospatial data and analyzing geospatial data, or use it even for applications. So many applications out there. So what I'm encouraging people try these tools that are out there. Not only GeoSpark. GeoSpark is one of them. There are tools also that work with Hadoop, like they extend Hadoop to do geospatial operations. To try them out, these tools are really will enable all your data science application, data analysis tasks, and will make it really scalable. Even if you don't have that big of a scale, hundreds of terabytes today, tomorrow you will have it, right?
Right.
So if you don't think about scale from now, you might need to go through a lot of code rewriting in the future or something like that. So I encourage people to try it out, play with it, play with the examples we have, and let us know because we are, as you mentioned, we're constantly changing the platform to accommodate the use cases that we see users using it. So we
Mhm.
see what benefits them the most because we want this to be made like we just don't build that for like because we just want to build it. We want to actually
Right.
benefit the users. Yeah.
Sounds good. And I think that's true. I think like what we see in general is when you get people, I mean, people often shy away from geospatial data just because it is, as we talked about in the call, like it's hard to work with, it's hard to scale out. But giving people tools to do that, I think opens up a new world of analysis and insight that can be gained from like thinking geospatially, which is really, really cool. Well, thank you so much, Mohammed, for joining us today. Sorry again for the slight technical difficulties we had at the start of the call. I encourage everybody watching this to reach out to you to learn more about Spark, GeoSpark, and give it a try.
Okay. Thank you so much.
Thank you. Bye.